So here we have a Java server up and running that we want to connect to a database. What database? Let's see. Let's create a brand new database here. And let's see. Schemas, new database. We'll call this cs5200, and this will be spring 2020. We'll apply. Some of the tables we might need from here. Let's create a brand new table. I guess we could close all these, right? We don't need all these. Way too many things. Don't save, don't save. And we don't want that either. Okay. Let's create a new table. So we can create the table either with the create statement, or we can create it just over here. We'll create something with a unique identifier that is a auto increment. So it automatically chooses this to be a primary key. And we'll create a couple courses, and the course might have a title, and it's a varchar. 45 is plenty, and it's called courses. So typically the naming convention in MySQL is to use plural, right? Plural nouns, right? Which is different from the way we name things in Java. Typically in a class you use a singular noun, right? You capitalize it and whatnot. In MySQL the capitalization doesn't really matter; it's ignored. Whereas in Java it's case sensitive. So we'll need at some point to reconciliate some of the naming convention differences. In Java, you use camel casing. Over here, the casing doesn't really matter, so we use underscores instead. So all these things need to be reconciled at some point. Since we're using JDBC, it doesn't really matter. We know what things are called. We'll just use them the way they're called. But next week, when we look at JPA, a lot of things are going to start happening for free and behind the scenes, and we need to know these differences, right? How to reconcile them. Anyway, so let's apply and recreate just that one table. There's our create statement. We'll say apply, and we can start adding something into that course. We can query and see if there are any courses. Obviously, there are no courses, but we can create a couple courses. We can say cs5200, cs5610, cs4550, and we can apply, and it creates all these inserts. And you can use these as samples to insert your own things into a database. Excellent. So we have some data. So let's try and connect to this database. We'll need to create a couple of users, right, with the correct privileges. I already have a few users in here. For instance, I have a cs5200 user that has exactly the same password. And I make sure that all my users are administrators, so they can do everything. They can insert, they can update, they can do everything, right? So they have administrative privileges, right? So as I log in, obviously, real users that you would create would have limited privileges, right? Usually they might not have capabilities of modifying the schema, right? They might only have read-only access, right? They can only read data. But my users, I made them gods, right? They can do everything. So let's use our cs5200 to log in. Right? So to log in, we're going to keep using our cheat sheet over here. We're going to use the driver manager to grab a connection. Right, so let's do that. Let's copy this and let's paste it in here. So this driver manager, it's asking me, where is this? What do I get that from? It says it's asking me, is it the class, the driver manager in the SQL library? Is that what it is? So import the class. So it imports it for me. There it is. It imports it. Notice that everything's going to be under the SQL package. Get connection, unhandle exception. So the get connection can throw an exception, right? So it's suggesting how to fix it. So should I add a catch to your already existing catch? Right. So you can do that. There's a couple more actions. You can either add a catch to this class not found and just do an or, right? Or you can add a brand new catch to each one of this, right? So if you're lazy, you can just add an or if you want to handle each catch exception independently, you could add a dedicated catch right? Usually it's considered to be best practice to have its own catch clause, right? And you treat that exception separately. So I'm going to add another catch clause underneath. Yes? Right. Let's see. The connection we're going to store in a local connection variable, which is going to be of type connection. Right. So it's asking me what type is that connection. Right. Where do I get that from? And it's asking me, is it Java SQL connection? Say yes. I'm going to say return, and that's what it's suggesting. So I'll say yes. So it'll import it for me automatically. Right. It imports it for me. So the IDE is kind of working with me. Yes. Once I have the connection, I want to connect to the right database. I'm going to connect to, what do we call it? cs5200 SP20. Is that right? What do you call it? Schemas. Yes, cs5200 SP20. And the username and password I'm going to use is my cs5200 user, which has got powers. All right, so that's going to give me the connection. Once I have the connection, I like to create a statement, right? That I can send a query. Right? I can send a select statement or an insert or an update, and I can create a variable here that can keep track of my statement. So import Java SQL statement. Yes. So statement. So I'm going to say here. So statement is going to be a connection dot create statement, and then this will be the SQL statement that I want to execute, right? So presumably something like select star from what was it? Courses. So courses. Again, it's case insensitive. Here I'm going to use capitalized, right? But it really doesn't matter. Create statement. Cannot resolve, yada yada yada. Isn't it? Create statement. I'm sorry. Create statement takes no arguments. Sorry about that. It takes no arguments. Once I have the statement, I can then execute a statement. I can say statement dot execute. I can do an update, or I can do a query. Execute query. And here's where I can provide my SQL, right? So here I can say select star from courses, right? And that is going to return a result set that I can then iterate over, right? So this is my result set. So results. I can't type today. I'm going to import the result set. Can't find it. Result set. Did I misspell it? No, there it is. Okay. Once I have the result set, right, I can start iterating for it. Now, yes. Courses. Okay. Sorry, English is not my first language. Courses. There we go. All right. Thanks. Now that we have the result set, remember, if we know that the result set is going to have just one row, maybe we're querying and looking for a particular course with a particular ID, and we know it's just one, then we need to advance the result set to at least that first row. Right over here, we know that's going to be lots of responses. Right, it's going to be an array of or a collection of results. Right, so we're going to need to iterate over it, and then we can iterate using while. So it'll be results.next. Right, it's going to allow us to advance the cursor forward, right, and then display access the data for that particular row. Once we are on a row, right, the results now gives us methods that allow us to retrieve values from each one of the fields. Right, right now we only have just two fields, right? We have the ID and we have the title. Right, we know the title is a string and we know the ID is an integer. Right, so we can retrieve the title string title by doing results.get. Now we know that what we're getting from a title is a string from the field, which is a varchar. So it's a string, and then the name of the column, which column you want to use, right? Which in this case is the title column. Right? We can also retrieve the ID if we want, as an integer ID. It'll be results.getInteger, right, and the name of the column ID. Right? We could just print this out if we want. We can say a string system.out.println, and we can print the title, and we can maybe print the ID. All right, let's restart the server, see if this blows up. Oops, what's going on? Application 8080 is already running. Yeah, I know. Why didn't you stop it? Shutting down. I thought it would stop it. Oh, because I have it running here. Yeah, I had it running here on the terminal. Let's try it again. Let's run that and let's see what it says. Okay, it still doesn't like that class, so I can't. It doesn't see it from. Oh, you know what? I think I need to restart the IDE. Otherwise, you won't see the class path. So the class path, I think it was loaded when the IDE started, and it hasn't been updated. So probably that's why the IDE doesn't see it. Let's try that theory. Let's kill the IDE. Let's bring it back up. Because notice, I think it's working just fine from the command line, right? We can do a maven clean install. But it's so much more convenient from the IDE, right? So let's run this again. Let's run this from the command line. All right, come on. Okay, and let's try and hit it. Let's refresh. Right, so it is working, right? It is connected to a database. It's getting a hold of the IDs and the titles. But again, it'd be so much more convenient if we can do it from here. Let's stop this server here and let's try it here. Let's run this again. Let's see if we can get it running from. No, my ID doesn't really. It's not catching my class path. Yeah, I don't know if I have to update my class path locally. All right, that's fine. We'll use the command line for now. All right, so we have this here. Ideally, instead of manipulating individual values, each individual IDs and titles and whatnot, typically we would like to have a data model. Right? We'd like to convert this low-level, right, unrelated fields, right, these numbers and strings into a data model up in a Java program, right? So more commonly, you'll have an entire data model here. Maybe over here we'll create a separate package, right, where we have all our models live under there, and in there we might have a Java class called course, not courses, right? Course, and in here you would have all the fields that you would need to represent a course in memory once it's loaded from the database, right? So you might have private int ID, and you might have private string title that represents your fields, your data in memory. You might also have setters and getters that go along with this. Code, implement, delegate, generate. We can generate both setters and getters. From all the input field, from all the class variables, we can say yes. So generate the setting. Well, actually, I want them, all of them, not just those, not this that one. Setters and getters for all of them. Okay, there we go. So we have setters and getters for those. We also might want a convenient constructor to go along with this, right? But notice that we already get the default constructor by default, right? We don't need to do anything. We get the default. We can just do a new course, and then we can use the setters to populate. Yes, or we can declare a convenient constructor, right? That takes in all the arguments, so we can generate that as well. So generate the constructor from all the fields. Right, so it creates a constructor for us, but now we don't have the default constructor, right? We don't get it for free anymore, so we have to explicitly create our default constructor, unfortunately. Even though we don't have anything in there of interest. That makes sense. Now the declaring everything private and declaring all the setters and getters and having at least a default constructor. Makes this a plain old Java object, a POJO, sometimes referred to, right? And it's following a standard called the Java beans, right? Where at least you have all the setters and getters. At least you have a no argument constructor, right? And also all these setters and getters follow a naming convention, right? Where they all start with setting or get. Yes. Also the names of the fields from outside, right? Notice that these are public, yes? And the private ones are not visible from outside. So I don't really know what the names of the fields are. I can't even look inside to look at these private fields, yes? The only way for me to guess what those fields are from the public functions that you are exposing to the rest of the world. Right? So I am presuming that you have a field called ID, lowercase, right? And that you have a field called title, lowercase. However you actually call it internally, I don't, it's not visible to me. But from the outside, it looks like those are the fields. And any other names from the outside, I'm always going to use these setters and getters to guess what those fields are. Whether you call them internally something else, right? I don't know, my title, whatever, right? It's entirely opaque to the outside world, right? I'm always going to go by whatever your public API goes by. Make sense? All right. So let's go back to our test. As we bring in all those values, the IDs and the title, we can instantiate a course. We can say we can create a course, course, and let's bring in that course, the brand new course we just created. Right there it is, the models course. And we're going to say a new course and provide the ID and the title. Right. So we have it. We have the course ID and title. We can perhaps keep track of a list of courses that we might want to return to you. So maybe we can create here a list of courses, and we can. So this list, I'm going to bring in the Java util list, and I'm going to initialize it as an empty list. So it'll be new array list of type course. Okay. Now that I have that, I can now just populate that list of courses here, saying course says. I can say add, and then add the course. Yes. Once I have the course, I can, instead of returning this simple string, I can return the entire course. I can say send back all the courses. Right? I can return all the courses. Now it's complaining that I had a string here, so it's actually expecting a list of courses. Right, a list of courses. And so let's restart this. I'm going to restart it, but I'm not going to execute it from here. I don't know. Actually, no. So it's still going to fail, isn't it? I'm going to have to do a main clean install. All right. It came back as an empty array at least, right? Let's see. Yeah, it's still complaining about this. Let me stop it here. Let's do maybe clean install. I'll debug the class path issue later. Okay, it's running. Let's try and hit it. Let's refresh. So now this time around, it did find the class path, right? It loaded all those rows, it iterated over them, and instantiated 3 objects and put them in our array list, right? And it's coming back to us in this format, right? Actually, it came back as a raw string. So the raw text that came back from the server is this, right? And what this format is known as JSON. This format is called as JSON. The reason it stands for JavaScript Object Notation. If this example would have been done maybe a decade ago, more typically we would have seen XML instead, right? It's XML. For quite a while was the standard way of exchanging data through networks, right? Since there has been a huge proliferation of websites out there, and a lot of folks are moving their applications to the web, this has now become the more common way of exchanging data across networks, right? Even if there's no JavaScript involved, the notation is nevertheless very, very popular to exchange data across, back and forth. So yeah, there we go. So we have data. You can notice here that I have a tool here that parses it and makes it pretty to look at. But the notation is very simple. It has an object is denoted by curly brackets. An object instance. An object instance is denoted by curly brackets. The fields here are all matching. Notice that they match exactly the model that we're using, right? The course model. But it's the names are not being taken from these private fields. They're actually being taken from the getters and setters, right? I am deriving the names of the fields, right, that I'm going to use based on your public API. Okay. Also, the values, notice that they're the correct data type. Integers are integers, and strings are just plain old strings. There might be an issue in that that in Java you have a much richer set of data types than there are available either in JavaScript or in SQL. There are a lot of data types in Java that are just not representable in SQL, right? And that's very common, right? In programming languages, more common, you have a much richer ways of representing data. Okay. All right. So let's keep working on this example.